In this video, we're going to be solving polynomial inequalities. So notice that for this example, all of our functions are the same. The only thing that we're changing is if it's less than, greater than, less than or equal to, or greater than or equal to 0. So we're going to begin by first factoring our function. And if we take a look at this function, we can see it's a special property because we can take the square root of 4 and the square root of 9. That's going to give me a 2x and a 3. And if I take 2x and 3 and I multiply them together, I get a 6x. And 2 of those will give me a 12. In order to get a negative, I need that to be a negative 3 right there. So I'm going to go ahead and factor those. Again, so that means I'm going to have a 2x minus 3. I'm going to have 2 of them, so that's going to be a quantity squared. So 2x minus 3, quantity squared, is less than 0. So I can really start all of these off as 2x minus 3 quantity squared. This would be less than or equal to 0. And this one here would be greater than 0. This would be greater than or equal to 0. So our first one, letter A, is talking about when we have less than 0, right? Less than 0. Less than 0. Now the square of any real number is non-negative. So what that means is it doesn't matter what's in here. If a positive comes out, I'm going to be greater than 0. If a negative comes out, I'm squaring it. And a negative squared, right? Any negative number squared is going to end up being a positive number. So it doesn't really matter what I have there. So we're going to have no solution for this first one. No solution. And so we would write that as the empty set. No solution. Now the inequality for part B is the same, except this time it's less than or equal to, right? So that means 0 will work. So what we're going to do is we're going to take our equation, 2x minus 3 quantity squared, and set it equal to 0, because we want to know what will make that a 0. So we can square root both sides, and that's going to give us a 0. All right, square rooting both sides gives me a 0. So I have 2x minus 3 equals 0. And then I continue to solve using some algebra here. So I'm going to add 3 to both sides. That's going to give me a 2x equals 3. I'm going to divide both sides by 2. And get x equals 3 halves. So in this particular situation, my answer is going to be 3 halves. Now, as we kind of talked about in that first problem, in part A, right, in part A, we said we can't have a negative number. Everything's going to end up being positive. So in this problem, in letter C, we're looking strictly for greater than 0. So we don't want 0 to be able to be an answer. Now, in problem B, we already found that 0 happens at 3 halves, and we don't want that. So what we're going to say is happening for our answer is that we're going to go from negative infinity all the way to that 3 halves that we found, and we're not going to include it because we don't want to have a 0. And then we're going to combine that, or have that be unioned with, from 3 halves all the way to infinity. So this is going to be our interval notation, and if I was doing this in set notation, then my answer would be x such that x is less than 3 halves, or x is greater than 3 halves. And that would be my solution. And on our last problem, we see that we have greater than or equal to 0. So that means that 3 halves that we found in problem B is totally fine now. So we can have all real numbers be our solution. So for interval notation, we could go from negative infinity all the way to positive infinity. And for set notation, we could say x such that x equals all real numbers. And that's going to be our solution. So that's what it's talking about when you're looking for less than or equal to, greater than, and greater than or equal to.